This is Pierre, a robotic system capable of playing flute-like instruments, controlling the main parameters involved in their execution. Its purpose is to experiment with the sound mechanism as well as to explore novel ways of music creation. This video will present an overview of the robot mechanism. One very important part of the robot is the artificial mouth we design. It channels the airflow into the flute labium, similarly to a human mouth. It is made of rigid and flexible parts, because when it interacts with the flute, it could get closer or further apart, and it is important to always maintain the contact with the instrument. Additionally, we place an actuator to move a tongue inside the cavity and another to shape the outlet of the mouth in order to create a wider or thinner airjet. This artificial mouth is mounted on a 3-axis system in the shaft of the third motor. This system gives us the possibility to move the mouth along the x-axis, the theta-axis and the pitch, or rotation over the y-axis, which we will call alpha. At the same time, the mouth is provided with a controlled airflow through a pipe system. An electric valve is in charge of controlling the airflow, and the upstream pressure is gotten with a silent air compressor. This system is mounted on a structure that holds firmly the flute on a known and constant position and inclination. Now, it makes more sense to express the position of the mouth in terms of its interaction with the flute. So we create a new coordinate system that has its origin in the labium of the flute and express the position of the end of the mouth as the effective length of the jet that would be blown into the instrument, its offset, and the incidence angle, which are more relatable to the parameters controlled by the musician. Therefore, a transformation must be applied to x, zeta, and alpha to get L, O, and theta. Finally, we have also created a system of fast linear actuators with short stroke to press the different keys on the flute. This system is customizable to adapt to different geometries of flutes, guaranteeing that the movement is performed orthogonally to the key in order to ensure a gapless close. 9 of these actuators have been arranged on a rail system, representing the 9 fingers used to play the instrument. Their configuration allows us to finger most of the notes in the flute. The coordination of all these systems is performed with an external computer, so the robot is able to interact with the flute, change the note finger, the flow of air blown, its distance, inclination and offset to the labium, and the width of the mouth. And with all these variables, rich and complex sound possibilities are achievable.